Hi folks, this is a paper on spiral galaxies. I don't usually work with spirals, and one of the reasons for that is that I've always found it difficult to get a reliable estimate of their total flux. The traditional way to do that would be to fit a simply parametrized model to their surface brightness distribution, and the most commonly used model is the Sérsic profile. But a Sérsic profile is quite simple, so what happens if you fit it to a galaxy with spiral arms like these? That's the main question addressed in this paper. And to answer it, I simulated images of spiral galaxies, like these ones, and fitted them with a Sérsic model. I tried varying different things, and the general result is that the Sérsic model leads to an overestimate of the total flux and the half-light radius. The amount of the bias depends, first of all, on how bright the spiral arms are, but also on their location, on the surface brightness distribution of the smooth component, and also on the depth of the data. To give you a few numbers, for a bulge-dominated galaxy with 10% of the flux in spiral arms, the total flux is overestimated by 15% and the half-light radius by 30%. However, if the smooth component of the surface brightness distribution is an exponential disk, then the bias is much smaller. So that's good news because most spiral arms are found in disks, but still, you can still find a good fraction of bulge-dominated galaxies with spiral arms. So that's still a problem. The root cause for the bias is the fact that the Sérsic model, especially if the index is large, puts a lot of flux in the outskirts, and it's very difficult to constrain the model there unless your data are really deep. So a better solution, in my opinion, is instead of trying to measure the total flux, which, by the way, it's not even well defined, is to instead focus on fluxes measured within a finite aperture, which we can measure much better. Thank you for watching.